Hi, my name's Stuart Peddle and I'm the Queensland Area Sales Manager for REDARC Electronics. In this instructional video, we'll be discussing the installation of the BCDC1240. The BCDC1240 is designed to keep your auxiliary battery at the maximum possible charge at all times. It features an MPPT solar regulator and DC to DC charger, both of which maximise the amount of charge available from the source at the time. The most important point when installing your BCDC1240 is that it is mounted as close to the battery that you are charging as possible. We recommend that it should be mounted within 1 metre of the auxiliary battery. If the battery you are charging is in the rear of the vehicle, it is suggested to install your BCDC in the rear of the vehicle also. If the battery you are charging is in a camper trailer or caravan, once again it is best to install the BCDC in the camper trailer or caravan itself. The BCDC is designed to be able to withstand the conditions commonly found in a vehicle engine bay, so engine bay installations are acceptable if this is where the battery to be charged is fitted. The unit is fully sealed to protect against dust and water ingress and is designed to run at full power up to 55 degrees. Temperatures between 55 and 80 degrees, however, performance will be downrated, so it is recommended to keep the unit away from direct engine heat sources. Recommended engine bay locations for installing the BCDC include the front of the radiator or behind the headlight assembly. Do not mount the BCDC next to the engine block, exhaust manifold or near the turbocharger. Selecting the correct cable size for your input and output wires is a very important consideration when installing your BCDC. Specific cable size recommendations can be found in the BCDC user manual. As a guide, it is recommended that both input and output power cables for the BCDC1240 are at least 6 B&S. For the BCDC1225, 6 B&S is also recommended. DC cables should be terminated using only quality connection methods. REDARC recommend Anderson connectors for where disconnection is required or butt splices for permanent connections. Probably one of the most common failure modes we see with BCDC installs once they're out in the field is melted fuse holders. It is important to select a good quality fuse and fuse holder. A good quality fuse and fuse holder will ensure a good electrical connection between the fuse and the cable on either side. We recommend MIDI-style fuses and holders. A poor connection means a high resistance, and a high resistance means excess heat is generated. Sometimes the heat generated gets to a point where the fuse blows prematurely, or the fuse holder gets so hot that it melts and the connections is lost. Sometimes the connection is lost on the inside of the fuse holder and this is not visible externally to the user. So if your BCDC is not turning on, it is very important to test the voltage at either side of the fuse holder itself. The common grounding of the BCDC, the input battery and the output battery is essential. This ground point gives the BCDC a reference for its input and output voltages, hence enabling it to correctly sense the point at which it turns on and off. It is important to ensure that the negative terminals of both the input and output battery and the ground wire of the BCDC all connect to the same place. This does not mean that they all need to connect to the same exact point on the vehicle, however, they do need to make a common electrical connection. The chassis of the vehicle is a good example of a common ground point. It is important to remember to check the continuity of your earth connections once installed. Some vehicles, in particular utes, can have the tray not electrically connected to the cab chassis. This can be an issue when installing the auxiliary battery in the tray. In this case, the tray may need an extra connection on the underside of it to achieve this electrical connection to the vehicle chassis. It is important that good quality terminals are used to ensure a good connection to the common ground point from the input-output batteries and the BCDC. Once we have mounted the BCDC, the wires should be connected in this order. Wire the common ground for both battery negative terminals and the BCDC ground wire. Wire the output battery positive cable, brown wire, to the output battery positive terminal via a fuse. Ensure that the cable is of adequate size. The cable is properly fused and the BCDC is a maximum of 1 metre from the output battery. Wire the input battery positive cable, red wire, to the input battery positive terminal via a fuse. It is imperative that the cable is properly fused and the cable is of adequate size for the length of the cable run. More information on required cable size can be found in the BCDC manuals. Next, the source select blue wire should be installed. Where the source select wire connects depends on the type of installation you are carrying out and will be explained later for each connection. Finally, the battery type orange wire needs to be connected. For a standard lead acid type battery, the orange wire should be connected to common ground. For a calcium battery, the orange wire should be connected to the input battery positive, and for AGM or gel type battery, the orange wire should be left disconnected and taped back to ensure that it does not touch another connection. Please refer to the battery manufacturer's specifications of maximum charge voltage, as these settings are only a guide. The charging volts of each setting can be found in the BCDC user manual. Also consider the temperature of the battery installation. If the battery is in the engine bay, the setting should be set to a lower charge profile. For example, a calcium battery in a hot environment such as the engine bay should be set on the lead acid profile, and a lead acid battery in the same location should be set on the AGM charge profile. This is because the gassing voltage of a battery decreases as the temperature increases. If the BCDC is to charge from the vehicle input only, the blue wire should be connected directly to the red wire. This will work for both 12 and 24 volt vehicle power systems. All other connections remain the same and the order of install should be followed. For an installation where the BCDC is to charge from solar only, the blue wire should be left disconnected or connected to the common ground point. This will work for both 12 and 24 volt vehicle power systems. All other connections remain the same and the order of install should be followed. For a BCDC installation where both vehicle input and solar are available, an external changeover relay needs to be installed. It is important for a diode or resistor suppressed relay to be used in this application. REDARC offer a relay kit suitable for both the BCDC1225 and BCDC1240. Its part number is RK1260. The relay should be wired in this configuration. More information on this setup can be found in both the BCDC and RK1260 manuals. This setup will ensure that when the vehicle is running, power comes from the vehicle, and at any other time, the power comes from the solar panels. The final stage of installation is an optional one. The BCDC offers the ability to be able to fit an LED on the dash of your vehicle to indicate its operation. Simply connect the green wire to the positive lead of a standard LED and wire the other lead of the LED to ground. And there you have it, it's as simple as that. Your BCDC is installed and you're ready to go travelling with hours of hassle-free operation. Never again will you have to worry about your food or beers getting warm.